Hello everyone, my name is Mohammed Mahadir. I'm going to speak about my project's vision-based forgery detection systems for document authentication using deep learning. My guide name is Mrs. Rahatia, assistant professor of ADS and ADS, and my teammates are Madesh and Abhinesh. These are the problem statement of my projects. What are the problems are trying to solve? The need to solve the challenges associated with the forgery of documents arises several issues in the documents, which is going to solve the several issues in the documents like that. Why is the problems important and what are the impact we are going to solve? Security and legal risks rising case of document frauds in the schools and like that. Need for scalable and automated solutions. What is a clear need for need demand for these projects? Idea in the target market, which is cost effective, real time verification and automated and scalable solutions. And these are the literature review of my projects utilizing blockchain technology of our university citation systems, and the publication date is August 2024, and visual complexity in Korean documents towards long specific data sets for deep learning based forgery detections, and the publication data is April 2025 of this paper literature review. And these are the objectives of my projects to implement blockchain for secure storage and tamper detections. We need to implement the blockchain for secure storage and tamper detection, and to implement one-time symmetric for encryption for secure data access, to mitigate risks for data breaches, and to offer increased security and integrity of storage certificates. To provide streamlined and cost-effective verification and methods to enhance employee verifications process for quicker and reliable results. These are the objective of projects, and these are the data collection of projects. We get the source of data from the Kaggles, like document image forgery detections and related certificates, like mark sheet like that. We get them through the Kaggle, and description of data size around 5,000 to 20,000 document images, and the futures document images, the actual scanned document labeled real or fake, and forgery type, what type of forgery it is, and metadata extra details, and dataset quality may contain noises from the low quality scans. Some forgery samples are synthetically generated, and the domain alignment directly supports document authentication and forgery detections. And these are the data pre-processing, image acquisition, grayscale conversion, noise removal denoising, and finally image resizing. We used image acquisition file to get the document input documents, which is captured by the scanner, mobile camera, or uploaded and they are uploaded to the image files like that, JPG, PNG, or PDF like that. They are going to upload and ensure that the systems has a digital version of the documents. Grayscale conversions, which is used to convert the color images into grayscales for higher accuracy, reduces computational cost while preserving important textures, which is used to they only get the important information and edge information. And that one is noise removal or denoising, removes unwanted disruption caused by the scanning or camera captures, like a pen or something in the paper. They're going to remove those disruptions. And the techniques used are Gaussian blur, Median flirting, and bilateral filtering. Preserves edge while removing noises. Image resizing, all images resized to a fixed dimension. Example, 224 into 224 or 128 into 128, like that for CNN compatibility. Ensure information for model training and testings. And these are the future engineering of my projects. Textual features, documents offer different printing, scanning, or tampering marks, and the shape and structural features. Forged documents may have mismatched fonts or irregular margins or signature disruptions. Most of the forged documents have the mismatched fonts or irregular margins, like that. We can use to predict them easily. Color and intensity of the features. Sometimes forged documents have the different ink colors or shades, like that. Some of the forged documents have them different patterns, seal colors, so that we can easily going to predict them whether it is forged or real one. Miniature features, miniature features used for biometric documents like ID cards and passports. And that final one is the dimensional detections. Exact features are for higher dimensions. Roadmap for the future engineering. They get the first input document and then go into the pre-processing, and then features extractions like texture, shape, deep features, and then finally feature selection and the output classification, whether it is output or whether it is forged or not. These are the system architecture of my projects. First, they get the my mark sheet as an input, and then they go to the recomposed images for like a grayscale conversion, and then go move to the difference of input images and these recomposed images, and then reshape the future input future image. Input image is processed for the forgery directions by CNN. Then finally, genuine or forgery images we get. These are the model implementation of my projects. Kaggle dataset of genuine and forged documents pre-processed and hashed on blockchain. Capsule CMS network trying to detect the tampered regions in certificates. Flashweb allows the user to upload document for verifications. Model outputs authenticate or forged with a probability score. Blockchain ensures data integrity and tamper proof verifications. Like that, these are the model implementation of my projects. Now we are going to see about my coding of my projects. We need to import TensorFlow for the TensorFlow as a TF for the deep learning library, and then image data generator. We use the image data generator for image pre-processing or accommodation process. MobileNet V2 for the pre-trained CNN models, and dense and dropout layer for the classifications. Ardent optimizer for the controlling landing. Callbacks for training controls. Stop early, save best models. This library helps us to build, train, and optimize deep learning models, and then creating the models, base models, which is to explain them. ImageNet, whether it is have the already trained of millions of images. It removes the original classifier. Top faults include as top removes the original classifier. Input size is 224 into 224 images. We use pre-trained model to save time and improve accuracy, which is those freeze-based models used to prevent the changing pre-trained weights. And then finally we use some global converts future maps into single vector, and dropout and output layers. The output layers produces whether it is fake one for 0 and a real one for 1. And we use batch size images per step, and image size input image, and approaches number of training images. And these are the evolution and refinement projects. Those tell about the approaches number of times, like that we can see, and then we move to the these are the output model output projects. These are the model output projects. And then these are the conclusion of my project. The project certificate locker represents a significant leap forward of academic credential management by integrating blockchain and advanced verification mechanisms and the innovative capsule CMS network. And this project successfully addresses the limitation of the traditional systems. And these are the conclusion of my projects. And these are the reference of my projects. These are the main reference of my 6 main reference of my projects. Now we are going to see about my real-time output of my projects. This is my output of my projects. Now I am going to tell about how the front end and back end is operate. So these are the now I am put them front end to operate. Now I am going to put back end to operate. So we need to go to the new cells and then put back end as a Python as a PI upload PI. And then we do run them. Now they are running in running. Now we are going to run the front end as in the Chrome, so that we need to copy this, and then we need to go to the local host, like that. The front end is going to down operate. Now I am going to put my input. Like that, we have two types of predators, original and original. They are going to find whether it is output original or not. Now I am going to put the original as input. They are going to find whether it is input or not. They don't know whether it is original or this is duplicate. Like that, they are going to analyze whether truth of the patterns of texture patterns, like that ink patterns. Then only they are going to find. Now I am going to analyze document. They say it's a original market. It's a confidence level of 52.0%. Now I'm going to put an example for the forged marksheets. So that we need to change them and to upload the another data set like for example for forged data sets examples. They're going to find whether it is original or not. They don't know whether it is original or fake one. They're going to analyze. They said the forged documents because it has some unpurposed textures like that background designs. So that's it's they said it's fake one. These are the project output of my projects. Thank you.